Okay, 6 years. Wanted to run through a very quick video about the benzoic acid experiment. You guys had asked me for a little bit of clarification with regards to this topic or with this experiment. So I'll just run through a couple of bits on this based on what I've looked back on with regards to the exam paper questions. It's usually split into two parts as I've got here, 1 and 2. Okay, and the actual making of the benzoic acid is something that comes up quite rarely, if at all. It usually ties in this bit, the idea of recrystallization or the idea of the melting point determination. So they're the two bits that I'm going to look at in most detail. And as I said, I've tied it in recrystallization and purification. We are recrystallizing the benzoic acid sample that we've got to purify it, to make it as pure as possible. And then with determining the melting point, you are essentially determining how pure the sample is. So that's why I've split it into two parts, and that's why we're going to look at each part separately. So you can see there, the first part, as I've said, the benzoic acid that we make from the intermediary or the intermediate product, which is sodium benzoate, and I'll touch on that later on. You can see that down the bottom there. That is the soluble part, so that's the bit that's going to dissolve. So the insoluble parts include the charcoal. The charcoal is one of the parts that is the insoluble part. So when we first do this, we are dissolving all of the benzoic acid in a small amount of hot water. The idea of keeping that to a small amount, or the smallest amount of water that we can, is to keep it as pure as possible, because if we dilute it too much, then some of it might not recrystallize. So we want to use a very, very small amount of hot water to dissolve it. First of all, we do a filtration to filter out those impurities, as I said, the insoluble ones, because they're not going to dissolve in the hot water, and they will be trapped in the filter paper as the sample goes through. So you can imagine I've got a funnel, got my filter paper inside, and I've got my sample of the benzoic acid. I'll colour it in blue with some of the charcoal in there as well, which is insoluble. As we pass that through the filter, the charcoal is going to stay there, and we're going to have the water, the hot water with the benzoic acid still present here, okay, as it goes right through. So we've filtered off the charcoal. As we said, it filters out the impurities. The way we do that then to cool it down or to crystallize the sample, as I want to have it in a powder form or crystallized form. So the way to do it is to cool this down. So usually what you'd do is that you'd plunge that into a beaker, a larger beaker full of ice water, and that's the way to cool that down nice and quick. You could also run it under the tap, as in the water would be running on the outside of the beaker and cooling down the solution that's on the inside. But sitting in a beaker of colder water with ice cubes there is probably the easiest way to do that. Then finally, we filter it again using the vacuum filter. So vacuum filter, as you've seen in the diagram, maybe it looks like we've got a ceramic kind of filter. So it looks like a plate or a pot in it's not glass, it's not see-through, and we have a kind of flat surface here, and it's porous, it's got loads of holes in it. So what we do is we put a flat piece of filter paper down, we pour in the solution, we pour in the crystals and whatever solution is left, and that's hooked up then to a vacuum pump, and that draws air out, so it sucks all of the water out, well, as much of the water as we can from the sample out through the vacuum or down here. And what that's also doing is that it's drying out the sample somewhat, so that the benzoic acid, I'll do it in green here just so we have it, is drying out as best we can, okay. So then we're at a point where we've got a pure sample. It's relatively dry, and the very last step is to, as you can see there, step 4, is that we do the evaporation. So same way as you guys had evaporated your salt water solutions, we put it on a clock glass, we set our benzoic acid sample in there, and we let the sun do its work and evaporate any of the other water off left, and we should have a dry sample of benzoic acid crystals left over then. So to finish off on that bit then, that's step 1, sorry. So step 2 then is when we look at the idea of the melting point determination. So the way that's done is we use our melting point apparatus. If I get rid of these, you can pause them, you can go back and have a look at the diagrams again, guys, if you so wish, but I'll get rid of them now to do the second step. When we have our melting point determination, then the setup that we'd use in our lab in school is very simple. We've just got like a metal block, which is like a cylinder shape, and it's got a hole in it that would hold a thermometer, and we've got another smaller hole that would hold a little glass tube. So we have very, very thin glass tubing, and we put a sample of the benzoic acid in there, and we pop that down into the hole that it fits into in the block, and then we would pop a regular thermometer in there also, and it would sit down in there, and then we'd heat the block very simply. Okay, so what happens is we heat the block up, and we can get a reading of the temperature. So the temperature of the block would equate to the same temperature as what the benzoic acid is feeling. And when we see the benzoic acid starting to melt, as we said, we've mentioned that it's a white powder. So if you think about that, if that white powder is being heated up like it would with salt or sugar or anything else, it then starts to form a clear liquid, and we see a liquid forming instead. And then that gives us our melting point, and all we have to do is just read the temperature from the thermometer there, and we'll get that in Celsius. You can change it into Kelvin if you so wish, and that's where it is. So that's all there is to it. Now, as we said, the pure sample is melted. We've discussed and showed you how to do that. The purer the sample, the higher the melting point. That's an important thing to remember. So the higher and higher the percentage of purity is, we'll have a higher melting point. In some of the exam paper questions, it's talked to you about having 2 benzoic acid samples, and one of them has a melting point range, let's say it's from 95 to 101, and then another one has a range of 102 to 103, say, let's just for argument's sake. And sample 2 in this instance has the shorter range, so it's more pure. 1, it's higher, and 2, it's more accurate in getting the melting point. So you can see there's a range of melting point between 95 and 101 there, which would be 6 degrees Celsius. In this case, it's only 1 degree Celsius. So that would show that we've got a more pure sample in this case. And I've mentioned that there. The pure sample also has a smaller range of melting point. So to tie this in then, the questions that are fully focused on this experiment that I've discussed, there's 2 there from 2011 question 3 and 2015 question 2 on the higher level paper. And they're really good ones to do. I would strongly suggest having a look back over that and running through those. Give it your best attempt, and then match your work against the marking scheme to see how you get on. There is no instance of this experiment coming up on the ordinary level exam papers based on what I could see. Back to 2005, I went as far back as there. Have another look yourselves. If you find one, let me know so I can tell the rest of the group, but I couldn't spot one myself. The very last thing I'll mention on this topic, always know your uses for these kind of things. It's usually a little 5 or 6 marker at the end of a question that they sometimes throw in, and it just gives you an extra little step to answer, and an easy way to pick up marks. As we said, benzoic acid is used for lots of different things, but the one I think is easiest to remember as a medicine, it's a fungicide, so it kills fungus or kills fungi, and it can be used in the treatment of athlete's foot. Okay, so something that you guys have all heard of before, so I'm sure that that's an easy one to remember, and that's why I would usually use that as my use for benzoic acid. The intermediate product, so we had three parts in the production part of the benzoic acid. You go from the start, and then you move into, and it makes sodium benzoate, and then we go on to make the benzoic acid. So the intermediate product is sodium benzoate. They may or may not ask that. Now, as I said, it's just as a little aside, just so you know. And sodium benzoate is used as a food preservative. That's an E number, so like it's E112 or whatever number it is. I can't remember, but that doesn't really matter. It's just that it's used as a food preservative to make food last longer on the shelf life there. So that's the run through of the benzoic acid experiment. And again, happy to do these on a number of more topics if you feel that they are warranted, or you feel that they're going to be helpful, beneficial for you. Thank you very much.